Today we're talking about rational numbers. A rational number is a number that can be written as a quotient of two integers. Show that the number is rational by writing it as a quotient of two integers. What does quotient mean? The answer to a division problem. So if a rational number is a number that can be written as a quotient of two integers, that means we have to write the number 7 as a division. So what can we do? We can say 7 over 1. This is showing that 7 is a rational number. What if we have the number -10? How do we show that -10 is a rational number? -10 over 1. How do we show that 5 3/4 is a rational number? Well, this is a mixed number. Can we write it as an improper fraction? 4 times 5 plus 3, so that would be 23 over 4. What if we have -3 1/2? 2 times 3 plus 1, 7 over 2, and we keep it negative, right? If we have to write 3/8 as a decimal, we have to divide the numerator by the denominator. Does 8 go into 3? No, 3 is not divisible by 8, so we have to add a decimal and a 0. What about 30 divided by 8? 3. 3 times 8 is 24. 30 minus 24 is 6. So we have to add a 0, bring it down. 60 divided by 8 is 7. 7 times 8 is 56. 60 minus 56 is 4. So add another 0. 8 goes into 40. 5. So if we have to write 3/8 as a decimal, that means 3/8 is equal to 0.375. If we have to write 5/11 as a decimal, we divide 5, numerator divided by denominator. 5 cannot be divided by 11, so we add a decimal and a 0. 11 goes into 50, 4 times 11, 44. Down to 0. 11 goes into 60, 5 times. 50 minus 5 is 5. 11 goes into 50, 4 times. 11 goes into 60. Do you see something going on? So what's being repeated? 4, 5, 4, 5. So we can write this as repeating 45, right? So 45 repeating. This line on top of the 4 and the 5 means that the 4 and the 5 repeat. 4, 4, 5, 4, 5, 4, 5, on and on and on and on. So 5 over 11 is equal to 0.45 repeating. Okay, we have to write the decimal as a fraction. So this is a terminating decimal. That means that it ends right here. It's just 0.7. The 7 is not repeating or anything like that. So we have to write the decimal as a fraction, and I'm repeating myself. We have to look at the place value of the last digit in the decimal to determine the denominator of the fraction. So what's the place value of the 7? 10. So we would write this as 7/10. Let's say we have -3.05. We have the whole number, -3. And then we look at the place value of the last digit. What's the place value? 100. So that would mean 5 over 100, or 500. Can we simplify this? -3 and 1. Do we have to order the following numbers from least to greatest? Well, we've got our decimals. Maybe we can use a number line. We can start by changing our improper fractions to mixed numbers. So this would change to what? 1 and 1/4. 4 goes into 5, 1, with the remainder of 1. Keep the denominator. This would change to what? 2 goes into 5, 2 and 1/2. 3 goes into 13, 4 and 1/3. So if I set up a number line, what is the smallest number that you see here? -4 and 1/3. Wouldn't negative, so let's say we have 0 here, 1, 2, 3, -1, -2, -3, -4, and it continues, right? So -4 and 1/3 would be somewhere around here. It would be -4 and 1/3, which was given to us as 13/3. Then the other negative, we have a -3 right here, -3, this one, right? Then we've got -1 and 1/4, that should be somewhere around here. -5/4, which we wrote as -1 and 1/4. Then we've got -0.2, that should be somewhere here, closer to 0 than to -1. -0.2. Now we've got 2.5, so we have 2 right here, so 2.5 is somewhere around here. And we've got 4.31, so if this is 4.31 should be around here. So have we ordered these in order from least to greatest? Using the number line help to place these in order from least to greatest. Something else we could have done was change all the fractions into decimals, and that would help us order the numbers from least to greatest.